Skymile Tower is a conceptual design for a soaring structure that has been envisioned by architects Kohn, Pedersen, Fox Associate in their vision of Tokyo, Japan in 2045. The mile-high tower is planned as a part of a resurgent megacity named Next Tokyo, which features a high-density eco-district consisting of resilient infrastructure that enables it to adapt to climate changes. The Next Tokyo concept has been developed for research and development purposes to propose an urban area for the low-lying coastal city faced with rising sea levels and increased typhoon risks. The tower and the accompanying city will be located on reclaimed land in Tokyo Bay and will feature a design based on sustainability, efficiency, reliability, robustness, and safety as key elements. Featuring a towering network of residential dwellings, the skyscraper will be home to approximately 500,000 residents and include basic amenities as well as latest technology. The tower exhibits a tapered form with vertical slots along its length that will serve as open-air sky decks, allowing the wind to flow through. It is designed to fit into a hexagonally shaped space and will consist of multiple sets of 3 interlinked building legs. The set of building legs are placed to overlap with each other in a sequenced format, creating sky lobbies at the point of overlap after every 320 meters. Each side of the building legs will have between 60 and 90 floors. The structure of the tower has been designed to bear the impact of the wind load. The inner side of the walls of the building will be mega braced, while the sides will have concrete shear walls. The 2 sets of building legs are connected by large steel trusses at the overlapping common floors. The steel structure is set in the form of plain frames that are bound by the concrete finishing. Small columns present at the perimeter will support the concrete floor framing and are further supported on belt trusses at intervals of 30 or 40 stories, transferring the load to the concrete shear walls. The skyscraper will feature an articulated facade that will enable cloud harvesting as a source of water. Water will be collected and stored at different levels and distributed using gravity, eliminating the need to pump it from the ground to the various levels, which would be expensive and time-consuming. The height of the super tall structure will help to reduce the heating load at minimal energy and financial cost by utilizing the cool air present at higher floors. Wastewater will be recycled mechanically and also through cloud harvesting and rainwater catchment systems. New and advanced technology will also be integrated into the tower, such as high-chrome multi-magnetic levitation elevator technology. Next, Tokyo will comprise a district traversing 12.5 km square on a man-made archipelago. It will be situated in Tokyo Bay between the coastal communities of Kawasaki and Kisaraju. The development has been conceived to protect the low elevation areas of the city against the perils of typhoons, earthquakes, and floods. It has been designed to include infrastructure elements such as faceted breakwater bars and operable floodgates to create flood barriers and provide defense against severe storms. The eco-district will also include hexagonal rings ranging from 150 meter to 1500 meter in width that will reduce the impact of the waves, allowing ships to pass through. Rings of varying size will fulfill different purposes. The smallest rings will be used to accommodate high-density development, whereas the medium rings will provide water storage. The hexagonal rings present at the perimeter will include low-density development, open spaces, and pedestrian routes. The plan will be transit-oriented with tunnels, regional lines, and a new vacuum tube transportation system based on the technology currently being developed by Elon Musk. The residential tower will have a built-up area of 1.375 million square meters and a density of approximately 25 meters a person. It will feature multi-level sky lobbies, shared public amenities, shopping, restaurants, hotels, gyms, libraries, and clinics. Leslie E. Robertson Associates is the structural engineer, and RWDI Consulting Engineers is the wind engineer. ThyssenKrupp is the vertical transport consultant, and the MIR and 3D Focus have worked on the renderings of the conceptual project. Why the need for the tallest skyscraper? The purpose behind Next Tokyo 2045 mission is to develop a mega city that is adapted to changing climatic conditions. The tallest skyscraper will be a powerhouse and will have space for everything ranging from agriculture to residential units to commercial activity. The tower will have gardens for agriculture while also have space earmarked for industrial scale agriculture. The elevators will be cable and will move in both vertical and horizontal directions. Thanks for watching this video till the end, and do subscribe to the channel to get the latest update of construction videos around the world.